All right, so we're gonna continue solving equations with rational expressions. All right, so we're gonna do two sets: teacher example, guided practice, student practice. What makes these problems a little bit different from yesterday is the fact that yesterday we just kind of started getting rid of denominators right away. For these ones today, we have to factor first because we're going to be dealing with polynomials instead of just monomials. Also, in the second set, the way you solve is going to be a little interesting as well. So it won't be just getting x by itself because it's going to be a quadratic, but we'll get there. All right, so let's go ahead and begin here. So example 1, of course, we want to solve for x. Okay? Solve for x. So I've got 1 over n plus 1 over n squared minus 2n equals 4 over n minus 2. Okay, so you'll notice that we don't have just monomials in the denominator anymore. We've got binomials now, right? And so that's our cue to start factoring. So, so step 1 is going to be to factor the denominators, just the denominators usually. So let's do that. Okay, n is not going to factor. Just leave the n alone. This one, how do you factor this guy?
You put into parentheses or something like that?
It's not a difference.
Or you factor out n.
You factor out an n. It's a GCF. So if I take an n out of there, what would be left inside if I were to take an n out? Okay. And this one here, it's nothing. We can't do that either. So that's it. So we have to do that. Okay? So now we get to do the same thing we did yesterday. Okay, we're going to multiply everything by the denominator. So what denominator do you guys want to multiply by first?
N minus 2.
All right, let's do n minus 2 then. So the next step then will be to do n minus 2. So I'm just going to start multiplying denominators. Start by rewriting it first, and then what I'm going to do is in green I'm going to put what I'm multiplying by. You guys said let's do n minus 2, so I'm good with that. I want to put those binomials in parentheses though. Okay, so does anything cancel over here on the far right? Yep, that's good. In the middle? Yep. How about on the left here? Nothing cancels there, right? Now, depending on what numbers here, you want to distribute, but since that's a 1, it's just going to be, yeah, it doesn't change, right? I guess I should scroll down a little bit. I can. Okay, so notice that it's a little bit simpler looking now, right? The 4 is no longer a fraction. The one in the middle here is a little bit cleaner. The one on the left here is still a fraction, though. All right, and then we're going to keep doing that. So now what do I want to multiply by? So we're going to multiply everything by n. Okay, so here, those cancel, right? Those cancel, and nothing cancels over there with the 4. So I've got n minus 2 plus 1 equals 4n. Yeah, we need to actually solve n, so we're not done yet. So no, I'm gonna do it. We'll get to names in a minute. So -2 and 1, we can put those together to be what? And how do I get this in with this in over here? Subtract it. So that goes away. And this is 3n. And then finally divide, right? So it's very similar. Almost 90% of the problem is identical to yesterday. It's just that that first step is different. It's where you have to factor the denominator first. Okay? So the last step there was solve for n. Okay? Now, if on your test, you're doing this and you see one of the options say no solution, you might want to go back and make sure that that doesn't make the bottom equal 0, right, by plugging it in. But if it doesn't say no solution as an option, then that's probably the answer. Okay? I wouldn't assume, because it's possible they would have both of these as an answer, this and then no solution, and maybe it's really a solution or maybe it's not. You just got to make sure that it's not extraneous by making sure it doesn't make the bottom equal 0. So that's our first teacher examples. Let's do a student practice. But what I really want to emphasize to you guys is that what's different here is the first step. The first step is what? Factor the denominator. So you got to remember all your factoring, right? It could be difference of squares. It could be GCF. It could be the box method. It could be any kind of factoring. In this case, it was a GCF problem. Okay? So let's go ahead and do another one here. This is guided practice, yeah. So we're going to go through this one step by step together. You guys are going to do most of the work, but we'll go through it together. Yes, guided practice. I'll label it. Okay, so here we go. I'm going to ask somebody's name. Oh, okay.
Who was that?
Augustine? What's the first step? Beautiful, thank you. Now, this is a harder question. I'm going to ask Alicia, though. Alicia, yesterday we didn't factor the denominators. We just started multiplying right away. How can you tell by looking at this that you need to factor the denominator first? Not sure, that's okay. Anything to know? Yeah? John?
There's x squared and 2 of them.
We had x squared yesterday.
Well, okay. What is it called? You can use the box method to factor them.
There you go. So he sees they're factorable. There's one. The answer I was looking for was this is a trinomial, this is a binomial, trinomial. The ones we had yesterday was just a single number there. It was a number with a letter or the power, and that was it. But when you start having like pluses and minuses, that's factoring problems. Yeah. Oh, yeah. Well, that's okay. But that's nice that it was in your mind anyway. That means you're tracking. So now I'm going to pause, and I want you guys to actually do the factoring. Now, before we do, I'm going to call on somebody again. I'm going to ask Nelson. Nelson, what factoring strategy will we apply here? That's a box method. Good. How about here? None. We don't factor that. It's going to stay exactly the same. And this is the same thing as the other one. So once you finish this problem, you're just going to copy it over here. It's the same thing, so you don't have to do it twice. So go ahead. I'm going to let you guys do that. Factor that one with the box method. I'm going to pause and let you guys work on that for a second. Yeah?
Is that a negative 12 or plus 10?
Where is it? It's negative 12. Negative 12. All right, so I'll pause there. Go ahead and factor. Okay. She's right. So after that, you guys, the rest of the problem is literally like last class. Okay, so at this point, let's go ahead and just go through it together. Gabriella, what do I do next? Okay, so Gabby wants us to start by multiplying everything by x plus 6. Okay, now every one of these is going to have something cancel, right? Boom and boom, boom and boom, boom and boom. Let's write it fresh. What's left here, you guys? Just a 1. There is no more fraction there. Okay, and now I'm going to ask Joanne, what's next? Multiply by x minus 2. Here. Now don't forget, even though this one's not a fraction anymore, you still need to multiply it. You have to do everything. So we're going to put an x minus 2 there, and I'm going to put an x minus 2 here. Okay, and so boom, those go away. Does anything cancel in the second one? No, that's not a fraction anymore, so that's just going to stay, but this goes away. All right, so here's what I have. 1 minus 1, parentheses x minus 2, equals 3. All right, and from there you go ahead and solve it. So why don't you guys go ahead and try to solve it. I'll pause here. Okay, so we distribute negative 1. All right, Chris, now what? Okay. Adrian, actually, just go ahead and finish up, Chris. And how do I get rid of that negative? How do we get rid of the negative? Okay. We divide by negative 1.
What happened?
Okay, so now somebody asked a good question, guys. They said, "Wait a minute, is that one of the answers that we throw away? Because you said it can't be 0." Now, I didn't say it can't be 0. I said the denominator can't be 0. I didn't say x can't be 0. The denominator can't be 0. So let me ask you guys a question. If I were to come up here, and plug in 0 here, would it make the bottom equal 0? No. If I were to plug in 0 here, would that give me 0?
No.
So we're good. That's a good answer to keep.
Can you scroll down, please? Where's that first zero from? You have negative x.
Around here for a second.
Student practice.
Yeah, I can only give you guys a couple minutes though, so use your time wisely. Yep, this is student practice. Okay, so all that really matters here is that you guys understand. What's that first step? Factor the denominator, right? So, they're 3's. All right, so guys, the answer here would be negative 7/3. Negative 7/3. I'm going to go through it, but I don't have time to do private conversations right now, but I'll go through it real quick because we have more I want to cover today. But here we go. And step 1.
You smack him. Do it.
Yeah, do it.
I wish you would.
Okay.
Ooh, that's a threat.
Multiply by 3 and then you Yeah.
Okay.
They give you-
By 3 first.
Yeah. They give you 3x minus 6.
Okay, so these go away, right? These go away. Now let's see what we have left. At this point I have x minus 6 over x minus 1
And then 3x
plus,
4.
I'm going to go ahead and just distribute. You don't have to at this step, but I'm going to. 3x plus
24.
12.
12, yeah, sorry.
And then over here, what am I got? What do I have? 1. All right. So now we go ahead and continue some more.
And then you multiply by x minus 1.
So now we're going to multiply everything by x minus 1.
They all cancel out.
So over here, that goes away.
Yeah.
This goes away.
Yeah.
Over there, nothing goes away.
And then what should we do with x minus 6 plus 3x plus 12 equals x minus 1. And then you combine your like terms on one side, which will give you...
Hold on a minute. Okay. Maybe it isn't 7 over 3. Oh, no, it is. It is. We're good. Okay. Yeah, it is. Here we go. So, put these together. What's that? What's this?
That's negative 6.
Now what?
Yeah, we did. You subtract the x, that gives you 3x plus 6. This is minus 1.
There you go.
Yeah, we did go wrong. 3x equals negative 7.
Once again, if you're on a multiple choice test, if you see no solution, you might want to go back and make sure it doesn't make the bottom equal 0. But if you don't, I would just say don't sweat it.
Can we
Because
get another
it's
practice?
Huh? Another practice. Well, I actually had another type I wanted to go over with you guys. Let's do one more type problem. Now, the next problem that we're going to do, the solving is different. So, the steps will all be the same, but by the time we get here, where we start getting x by itself, we're going to have to do something a little bit different, okay? That's it. So, here we go. Let's see what we can pull off. Who said that? Hannah? Bad person. All right, here you go. Example 2. So this is a teacher example. I'm going to walk you through it, and we'll see how much time we get to practice this one. Time to get a watch.
Oh, he's on here.
I did. I got on her head.
My phone's charging. It's too far.
Okay. So here we go.
Ew, that's ugly.
Paris. What's my first step? Good. Factor the denominator. All right, so we factor the denominator. Now I'm going to go ahead and do that. Excuse me.
6 plus.
That's a smudge. You guys could ignore that little smudge after the 3 there. Sorry.
Ooh, can I save that?
Jonathan, what method would I use for this?
Oh, I got a fast one.
Box method.
You're
Minus 6 and plus 4.
All right. Now, just so you guys know, usually, whatever one of them are, see that one I have here? That'll probably be one of the ones over here, just so you know.
It's minus 6 plus 4.
Because if they don't make them match, then you end up having to multiply a whole bunch of stuff, and it gets to be really too much of a pain in the butt to worry about at that point. Some of you guys are like, well, it's already a pain in the butt. Well,
Mr. Bailey, I have a question.
what's up? Thank you.
For that one, it's two denominators can be factored with the box method and the other is m minus 6. Since we see the m minus 6, don't we already know that the m minus 6 is going to be a part of the
Yeah,
factor?
that's what I was saying. So, I mean, it's not a guarantee, but usually, yes, you're right. Okay, so now we start multiplying. Okay, so what do you want to multiply by first?
M minus 6.
All right, m minus 6. Here we go.
Bless you. Bless you.
Okay, we get to cancel here. We get to cancel here. We also get to cancel here. What am I left with here on the left? What about here? Good. And over here?
3 over m plus 4. Then you multiply by m plus 4. Cancel the other two denominators.
Okay, so now this is where I'm going to pause for a second.
Is it different?
Because this is where things get a little bit funny. Mm-hmm.
Because of what?
Mr. Bailey, this is too much.
Honestly.
You're quizzing, you're testing us on crazy. We're not even gonna be here tomorrow on this.
All right. What do I do now, guys?
Wait, we have a test on
Plus 4.
We're going to multiply by m plus 4. Okay, now here's something I want you guys to pay attention to. Might want to put a little star next to this because this is one of the things that's different here. Is right here.
what?
Okay. Now there's two things. First of all, you have to know how to do that. The second thing is that I'm putting parentheses on these. I want you guys to do that too, because I bet a few of you guys are going to do this. A lot of you guys are going to do this. You're not going to put parentheses on this, and you're going to think it's just the m times one of them or something. So you've got to get used to putting your polynomials in parentheses, because if you don't do that, you're going to miss some stuff.
Are you shoving it in a box?
It will be a box problem, yes.
Hell
Heck yeah, young man.
yeah. Or Jess.
Okay, so
Oh, yes.
right now I have this plus what's here now? Equals. Okay. Now, I'll show my work for this, but I assume you guys probably know how to do this already, but I'll show my work, okay?
I already know from the electric socket.
So we're going to do m plus 4 and m plus 5. So we have m squared plus 4m plus 5m plus 20.
What? You just didn't combine them.
I didn't combine them. But if that's confusing and you want to just do it mentally, I'm okay with that. That would be 9, right? But there's all my numbers from the box. And then don't forget this guy. Bring down your 1, your equals, and your 3. So that's one difference right there, is that you may end up with a binomial times a binomial, so you have to do the box method to multiply it. But there's another difference coming up. Okay, what else is different this time, you guys?
There's no m or m squared.
I think we're getting close there. So here's the answer I wanted to hear from you, Hen. You've been doing really good.
Oh, yeah.
Stay with it. All right. So here's the main difference here. So I'd like you to start this.
I have a question.
No, because the m squared doesn't have one to offer. So I'll show you how to solve it. We are going to factor, but not quite yet. So here's the main difference I want you guys to notice. There's an m squared and an m. Okay? That's a quadratic. Now there's two ways to solve a quadratic. One is by factoring, which is what we're going to do. The other one, if you want to, you could do the quadratic formula. But it doesn't matter which method you want to go with. In both cases, it can't equal 3. It has to equal what? Somebody said it. 0. It's got to equal 0. So this is where the solving gets a little bit different. So we're going to minus the 3 on both sides first. So what's over here now? 0. And this leaves me with what here? 18? So like I said, at this point, you could either do quadratic formula or factoring. I'm going to solve it with factoring. Maybe. Let's see if you're right. Yeah, you are right. Now, I'm not showing my work for this, but it's the box method in this case because there's 3 terms, right? You would do the box method to factor that. Jonathan's got, yes, but in different ways, right? The first time I did it, we had the numbers outside and we multiplied in. This is the one where you start inside and pull it out. So you're doing box in 2 different ways. After you do your box method, you set them both equal to 0, and you solve both. So this is a big boy problem or a big girl problem.
Don't say it like that.
Well, there's a lot going on in there, a lot of algebra.
So we just have 2 points now. That's it.
You end up with 2 answers. I'm curious, will either of those numbers make the original denominator equal 0? Take a look at it.
Okay, so I don't think we need to say so.
They don't? So they're both good answers? I want to look myself, but I'm getting a pretty confident no back there. So we got -6, and what else?
-4, -3, -3.
-3?
-6 and -3.
Yeah, neither one of those will make the bottoms equal 0, so we're good. All right. 6 minutes? Do you think you guys can do it?
No.
You don't
Yes.
believe in yourself?
No.
Yeah.
I believe in you.
I believe in myself.
I believe in you so much that if you don't solve this problem by the bell, you don't get to leave. That's how much I believe in you. Oh, yeah. Student practice, baby. It's got to be perfect, or else you and me?
Wait, are you being for real? Do we have a choice to do it?
No.
What the freak?
I'm going to stand at the door. And your ticket out this door is the correct answer. Yeah?
Mr. Bailey,
I believe in you.
We have a class every day. Yeah, you should put the answer up there